So we are working on multiplying square roots, or sorry, multiplying radicals. So one more time, this is not my worksheet. We're just working on it together and figuring out what we can do. So unlike adding and subtracting your radicals, where we used to just keep the number on the inside, when it comes to multiplication, we can kind of rewrite them so that we're multiplying your outside term. So 4 times 1 is just 4. And then we get to multiply your inside term. So we have 4 times 6 times 6, which is 36. So the square root of 36 is 6. And then further combine for 24. Okay, so the big difference from adding and subtracting is that we can now actually combine the number on the inside. So if we're looking at 3, we have negative square root of 2 times 3. So we can bring them together under the square root sign. For then negative square root of 6. Now, the square root of 6 cannot simplify any further. So your answer is negative square root of 6. Now try and pause the video and see if you can come up with the remaining odd ones. So we have 12 times 15. So we can actually, what we can do before we get started, 12, do we really want to multiply 12 and 15 and get a massive number? No, but perhaps we can break up 12 as 3 and 4. So the square root of 4 times the square root of 3, which is then square root 2 times 3 times the square root of 15. Now it's much easier to multiply 3 times 15, more so than 12 times 15. So we get 2 square root of 45. Now the square root of 45 has a perfect square in it. That can simplify just a little bit more by 9 times 5. So 2 root 9 root 5 can now be 2 times 3 square root of 5, or 6 root 5. Now the reason why it had to be simplified again was 15 also had the square root of 3 and the square root of 5 in it. So then you got that double number. So let's try it again over here. So 20, so 5 times 20, actually, we can multiply out. So the other version of that is 5 times 20. If you can recognize, well, that multiplication isn't bad, but even better, it provides us with a perfect square, then that would be lovely. Now, let's say you didn't take this root, but instead you did out square root of 20 to be the square root of 4 times the square root of 5. And then you went to, okay, well, the square root of 4 is 2, and it still has the square root of 5. So you get negative 6. The 5s come together to get 25, right? But then you still have to pull it out. Negative 6 times 5 will give you to negative 30. Okay, so sometimes see if you can multiply them together. If it's easy, if it's not like 12 and 15, that would produce a big number that's kind of hard. You can start to chip away at it first. And we're going to end that there. Actually, we're also going to go over dividing. So dividing rational or radicals, we can take the tactic of, okay, first, can they reduce any further? And if not, we can also see, okay, well, them being under a square root sign, can we bring them together just like we did with this multiplication? So multiplying them together. Now, it kind of depends on what strategy you have to do, or what variation you're given. So 8, even if we had 8 divided by 7, that doesn't give us a very nice number. So instead, we can try to evaluate your numerator and your denominator separately. So if you're looking at your numerator, we've seen the square root of 8 being written as the square root of 4 times the square root of 2. which is then equal to 2 root 2, all over 7, the square root of 7, I should say. So again, you can one more time see if you can divide these two, which are under the same root, which is only possible if you can do it under the same root, the same radical. So if this was a 3 and this was a 2, you can't do that. So 2 divided by 7, again, doesn't give you much to work with. So instead, now you have to rationalize. To rationalize means to simplify the denominator. So in order to get out this radical from the denominator, we're going to multiply by itself. The easiest way to get out is to multiply by itself. You can certainly multiply by other numbers to make a perfect square, but sometimes that can be a little bit tricky if we're not sure what number could be perfect. So we have 2 root, and then 2 times the times 7 under the square root will give us 14. And then on the bottom, if we were to multiply 7 times 7, that'll get us to the square root of 49, which we know to be the square root of, or sorry, not square root, will be 7, because you see the pairs. So rationalizing the denominator, as long as you multiply by itself, it'll create that same number in the bottom. Now you cannot divide 14 and 7 and make it 2, because this is really the square root of 14, which is its own number. However, you can look to see your outside coefficients if they can simplify any further, in which case 2 divided by 7 doesn't simplify. Now let's try it again. So again, take a look. Can 2 and 6, can that kind of combine to make our life a little bit easier through division? A little bit, not much, but 2 divided by 6, if it's all under the same root, is 1 over 3. Now, as long as you finish that division, and if this square root remains, so if there's no perfect square in it, then we can go ahead and break it up one more time and evaluate them separately. Now, the square root of 1, right? Is that a perfect square? Square root of 1 is. It gets lost in the mix. Some students forget that it's a perfect square, but keep in mind, 1 times 1 is itself. So that's considered your perfect square. So you still have the square root of 3, which unfortunately is not, we can't do anything with it. So again, we have to rationalize. So multiplying it by itself will create a perfect square. So you have the square root of 3, or square root of 3 times 1 if you want, times, or sorry, divided by 3. Again, these can combine to make the square root of 9. The square root of 9 is 3. So your final answer is 3 root 3. Trying again with 15, we have the square root of 3 over 6 square root of 7. So 3 and 7, even if we try to divide them, they're not going to work really well. So instead, we can again, once more, rationalize. So rationalize, multiply by the square root of 7. We get 21 up top, and then we get 6 times 7 below. So 6 times 7 is 42. So the square root of 21 over 42. Let's see, let's try 17. So 15 and 6, they do have something in common, so we can try to bring those under the same root. And you can just say 3 over 1 if you'd like to kind of keep them even. But we have, let's see, 5 over 3. Oh, sorry, so sorry. 5 over 2, square root of 1/3. Now, because that no longer simplifies, you can then bring it back to its original, in which case the square root of 2 we need to rationalize so we can multiply that out. So you get 10 over 3 times 2, which is 10. Well, actually, 10 has a 2 in it, so 2 times 5, so that'll cancel. So you're left with 5 over 3. Now I'm going to give you an extra one. Let's say we have 64 divided by 40. Oops, I'm sorry. 64 over 49, and it's under one single square root. Now, are they divisible by each other? Unfortunately, no, they don't simplify any further. But what do you know about the square root of 46? Or sorry, 46, the square root of 64, or the square root of 49. Well, they are in fact perfect squares. So if we were to break them up, we can evaluate them separately. So the square root of 64 is 8, and the square root of 49 is 7. So keep in mind, you can go backwards. So if it's under one square root sign, you can break it up into 2 if you can recognize that these are a little bit simpler to tackle. Now the remaining problems are over here in case you want to try those out on your own.